Here is our introduction to metric relations. It's a small unit in the whole triangles chapter. And we know that when we have a 90-degree triangle, we can use Pythagorean theorem. What's interesting here about metric relations is that we have that 90-degree triangle that we're used to seeing, and then from the 90 degrees, we drop down an altitude, making a 90-degree triangle split with two other 90-degree triangles, okay? So there are a series of ratios here, where here you have a large 90-degree triangle. So I labeled this as the big. So if we were to flip this one that way, okay, we would get here, okay? And then that 90-degree triangle was then made there, where that became a medium size and a small size triangle. So here we have metric relations is a series of relationships when you have a 90-degree triangle inside a 90-degree triangle. So in order to use metric relations, we know very well that we have what's called an altitude, that's h, and it also creates a 90 degrees. So we have three triangles in total. We have the large one, okay, which would be your A, B, and your C, okay? So that's this one where you have your general Pythagorean theorem, right? Actually, instead of doing that, I'll just make that's your big one, okay? And then let's change colors. So then we have A and M, okay? Those are medium, okay? So A will be larger than B and M will be larger than N in general. So we have the medium triangle, which I make in blue. And then let's go ahead and make this small one, B, N, and H would be your small triangle, okay? So in general, if I were to draw this again, okay, I have a large 90-degree triangle, and then the altitude came down, and then it created another large triangle. Now we know that this would be A, B, and C. So then what we're adding to the picture now is we have M, N, and H. Now the way I like to put it is M comes before N in the alphabet, just like A comes before B in the alphabet. So A and M will be together, and then B and N will be together, where A and M come first, so they're the larger ones, and B and N come second, so the smaller ones. So as long as they're always paired together, you'll be good to go, okay? And then we have a series of relationships. So the ones that we know by former knowledge, okay, let me get a different color now, would be our Pythagorean theorem. So let's say I have A and I have B, and I want to find C. Well, I can use Pythagorean theorem. Same goes in the smaller triangles, where if I have A squared and I have M squared, will also give me H squared. And in the small one, that also means that N squared plus B squared will give me H squared, okay? Just double checking, yes. So H, no, I lied. I made a little mistake here. Also because what I'm doing now, we're not often using, but I want you to see that they're possible, right? So here B is the hypotenuse, and here A is the hypotenuse. So I'll write them here. So here we see that M squared plus H squared equals A squared. And here you see that B squared plus N squared equals, no, I did it again, funny. Where N squared plus H squared equals B squared, okay? So those are just, in principle, again, Pythagorean theorem is helpful, but it's not what we're really gonna focus on. So we see that now C has been split into N and M. So a relationship that we wanna know is that M plus M equals C, okay? So N plus M equals C, which means if I have N but not M and I have C, well then I know C minus N equals M, right? C minus N equals M, and then if vice versa, if I have M and I have C but I don't have N, I know that C minus M would give me N. So these ones are the more basic given ones, okay? But now let's highlight what we really want to know. So on your memory aid, you definitely want to make sure that you have the original grid here. So I wish I can go back. This one, okay? You want to have this, and then you want to have these relationships where, let's start with h squared equals mn. So h squared equals m times n, okay? Here's for the medium and for the small triangles. So a squared equals c times n. So a squared equals c, this whole length, times m. And b squared equals this whole length times n. Okay, so b goes on this side, the smaller side, relative to our c, and then a would be m and c. All right? And then a beautiful one that has all the letters, or almost all the letters, is a times b would equal c times h. So in metric relations, you're going to be given a series of the side lengths. And depending on what you're given, you might use your Pythagorean, you might use m and c to get n or something like that, okay? To then ultimately plug into one of these four ratios or relations, as we can call them, to find our missing value. And I have 3 examples coming up, so I'll see you there.